Hey, Zion here,
And Benson here,
your Math Quest Maestro. Now for today's Math Quest, we're going to talk about simple and general annuities. Now Benson, tell me, do you have any idea what our quest is all about?
I understand what simple and general is, but annuities, I think I never heard it before.
Oh dear, I think we're going to have some problem, or we're going to have some difficulties in our quest for today.
Let's check our adventure map, shall we?
Yeah, let's go to the arena now.
As previously mentioned, our quest for today is all about simple and general annuities, and let's see what challenges await us, as well as the knowledge treasures for this math trial.
In this quest, we're gonna learn about
Annuity definition, simple annuity and general annuity overview, distinguishing simple annuity and general annuity, simple and general annuity definition of terms, solving simple annuity and solving general annuity.
Annuity, a regular payment of a fixed set amount of money paid to someone with interest compounded at a fixed rate. These regular payments are equal in amount and made at regular intervals, such as monthly, quarterly, semi-annually, or annually. Examples are rental payments such as your monthly payment for your apartment, lease payments on a car, mortgage payments, life insurance, pension plans, and different kinds of loans.
it's annuity, huh? Easy peasy.
Let's see if that will change. There's still more.
Under the umbrella of annuity, we have our main quest, simple and general annuity.
So, how are they different?
Well, simple annuity is an annuity where the payment interval is the same as the interest period, while general annuity is an annuity where the payment interval is not the same as the interest period.
I don't quite get it.
Okay, let me give you some examples, but you have to distinguish what kind of annuity it is. Harold pays 8,000 pesos for his motorcycle loan every month for a year with a 5% interest compounded monthly. This is an example of simple annuity, since the interval period, which is 1 month, is equal to the interest period, where it is compounded monthly as well.
Alright, I get it now, thanks.
Here's another one. A payment is made every 2 months for a loan with an interest rate of 3% compounded quarterly.
Ooh, that's general annuity.
Correct, since the 2 months there is not equal to the interest which is compounded every 3 months. Let's have 2 more examples. Leos pays a fixed amount of money each year with a 10% compounded semi-annually.
This is a general annuity.
Right. What about this? Morven deposits 2,000 pesos every 3 months from his account that earns 3% interest compounded quarterly.
Well, this is a simple annuity.
That was cool and fun, but let's proceed to the next one.
Alright, but we're not in the solving part just yet. First, let's define the different terms and elements that will be helpful to us in the solving process.
Future value of an annuity. It is the sum of future values of all the payments to be made during the entire term of an annuity. Present value of an annuity. It is the sum of present values of all the payments to be made during the entire term of an annuity. Regular or periodic payment. It is the amount of each payment. And lastly, term of an annuity. It is the time between the first payment interval and the last payment interval. Now let's proceed to the part where we solve simple annuities. But of course, we will need the formulas that will guide us in this challenge. In solving the future value of a simple annuity, we have r times 1 plus r over m raised to the power of m times t minus 1 divided by I. Or simply, r times 1 plus I raised to the power of n minus 1 divided by I. While in solving for the present value of a simple annuity, we have r times 1 minus 1 plus r over m raised to the power of negative m times t over I, or r times 1 minus 1 plus I raised to the power of negative n over I. And lastly, in solving for the regular payment of a simple annuity, we have 2 formulas, and the usage of these formulas depend on what is given. If the future value is given and the present value is not, we may use f over 1 plus 1 raised to the power of n minus 1 over I. But if the present value is the one given and the future value is not, we may use p over 1 minus 1 plus I raised to the power of negative n over I, where f stands for future value, p for present value, uppercase R for regular or periodic payment, lowercase r for rate, m for conversion period, and t for term or time.
Now we should take note that the time should be in years, and if the given in a problem is in months, we just have to divide the given number of months by 12. Additionally, to get the I or the periodic rate, we just have to divide the rate by the conversion period, and to get the n or the number of conversion periods, we just have to multiply the conversion period and time. I think we're good to go. Now let's start. Solving the future value of a simple annuity. In solving for the future value of a simple annuity, we will use the formula f, which is a future value, equals r times 1 plus I raised to the power of n minus 1 over I.
Problem number 1. Mr. Severus wants to save 5,000 pesos every month on a savings account that offers 10% interest compounded monthly. How much would his savings be after a year?
Feel free to pause this video if you want to solve it by yourself. Now let's first identify the given elements. We have the r, which is 5,000 pesos, the rate 10% or 0.10, m conversion period, which is 12, and time 1 year. And we also have to get the n, which is the product of m and the t, and that gives us 12 times 1, which is equals to 12. That's our n. And the I is r over m, which is 0.10 over 12, and that will give us the result 0.0083. Now that we already know the needed elements for us to solve for the future value of a simple annuity, let's get going. And yeah, the formula is there, and let's just substitute the elements that we have, and that will give us f equals 5,000 times 1 plus 0.0083 raised to the power of 12 minus 1 over 0.0083. And there, our future value is 62,816.21 pesos. That means Mr. Severus will have 62,816.21 pesos savings after a year.
Luna plans to save 3,000 pesos every 6 months in a fund that gives 6% interest compounded semi-annually. How much money would she have after 3 years?
So let's get the given. We have R, 3,000 pesos, the rate, 6% or 0.06, the conversion period, 2, and the time, 3 years. Then we'll also get the N, and that gives us 2 times 3, which is 6, and the I, R over M, 0.06 over 2, and that gives us 0.03. Now we can evaluate. So we have f equals 3,000 times 1 plus 0.03 raised to the power of 6 minus 1 over 0.03. And that gives us the future value, which is 19,405.23 pesos. That means Luna will have 19,405.23 pesos after 3 years. So there, that's how we solve for the future value of a simple annuity. Let's proceed to solving the present value of a simple annuity using the formula P equals R times 1 minus 1 plus I raised to the power of negative n over I.
Problem number 1. Fred expects to receive 2,500 pesos monthly for 5 years from the savings he had with an interest rate of 7% compounded monthly. What is the present value of his savings in this annuity?
There, let's determine the given. We have R, which is 2,500 pesos, the rate 7% or 0.07, the M 12, the T 5 years. And let's also solve for N, which is 12 times 5, 60, and I 0.00583. There we can evaluate now. So we have P equals 2,500 times 1 minus 1 plus 0.00583 raised to the power of negative 60 over 0.00583. And we have the present value, which is 126,267.02 pesos. That means Fred currently has 126,267.02 pesos in his savings.
Now next problem. Good for 4 years, Mrs. McGonagall will get 6,000 pesos every 3 months from her trust fund. If it has a 12% interest compounded quarterly, how much is the present value of the money in her trust fund?
First, let's determine the given. So we have R 6,000 pesos, the rate 12% or 0.12, m is 4 as well as the time 4 years. The n we have 16 and I 0.03. Now we can substitute it to the formula, which gives us 6,000 times 1 minus 1 plus 0.03 raised to the power of negative 16 over 0.03. And we have the present value, which is 75,366.61 pesos. And that means Mrs. McGonagall has 75,366.61 pesos in her trust fund. Future value of a simple annuity, check. Present value of a simple annuity, check. Now let's proceed to solving the regular payment of a simple annuity with the formula, which is R equals, if the F is given, then it's going to be F over 1 plus I raised to the power of n minus 1 over I. And if P is given, we will use P over 1 minus 1 plus I raised to the power of negative n over I. Problem number 1. Mr. Godric borrowed 10,000 pesos and agreed to pay an equal amount of money every month for 2 years. How much should his monthly payment be if the interest rate is 6% compounded each month? In this problem, what do you think 10,000 pesos is? Is it a future value or a present value? That's right, it's a present value. So we will use the formula with the present value. But first, let's determine the given. So we have the P, which is 10,000 pesos, rate is 6% or 0.06, M is 12 and T is 2. And we'll also get the N, which is 24, and I, which is 0.005. Now we can substitute it to the formula, and we'll have 10,000 over 1 minus 1 plus 0.005 raised to the power of negative 24 over 0.005. And that gives us a regular payment of 443.21 pesos. And there we have a regular payment of 443.21 pesos. That means Mr. Godric pays 443.21 pesos monthly. Now let's go to the problem number 2. Mrs. Lestrange plans to have a savings of 25,000 pesos for 2 years in an account that gives 5% interest compounded monthly. How much should she pay every month? So in this problem, we have the 25,000 pesos, and as we can see, it is the future value. So we will use the formula with the future value. And now let's identify the given. We have F equals 25,000 pesos, the rate 5% or 0.05, the M 12, and T is 2 years. And to get the M, we have 24, and I is 0.00147. Now we can substitute that to the formula now, so we will have 25,000 pesos over 1 plus 0.00417 raised to the power of 24 minus 1 over 0.00417. And yeah, that gives us the regular payment of 992.58 pesos, which means Mrs. Lestrange pays 992.58 pesos monthly. Well, I hope you learned about the first part of our quest, which is to solve simple annuities. And now, without further ado, let's move on to solving general annuities. In solving for general annuities, these are the formulas that we will use. So for solving the future value, we will use R times 1 plus I raised to the power of n minus 1 over I. For the present value is R times 1 minus 1 plus I raised to the power of negative n over I. And for the regular payment, just like the simple annuity, we have 2. If the future value is the one given, we will use F over 1 plus I raised to the power of n minus 1 over I. And if the present value is given, we will use P over 1 minus 1 plus I raised to the power of negative n over I. Problem number 1. Bathilda pays 1,500 pesos every month at a fund that offers 5% interest compounded semi-annually. How much money would she have after 3 years? Moreover, for solving the I, we have a new formula. So it's going to be 1 plus R over m sub 2 raised to the power of m sub 2 over m sub 1 minus 1. And for n, we will use m sub 1 times t. So as we can see, there is m sub 1 and m sub 2. So what's the difference exactly? So I'm going to tackle that as we move along. So in solving for the future value of a general annuity, we will use the formula, which is F equals R times 1 plus I raised to the power of n minus 1 over I. And the two formulas for I and n, the ones I mentioned earlier. So first, let's determine the given. We have R, which is 1,500 pesos, the time 3 years, and the rate is 5% or 0.05. Now, the M sub 1. So the M sub 1 is a conversion period of how often the amount is paid. So here, the amount is paid every month. So that means it's 12, the conversion period. And for the M sub 2, it refers to how much the interest is compounded. So it says semi-annually, so it means it's 2. So M sub 1 is how much the amount is paid, how often the amount is paid. And M sub 2 is how often the interest is compounded. Before we proceed to solving the future value of this general annuity, let's first solve for the periodic rate, the I, and the number of conversion periods, N. So for I, we had the formula, which is 1 plus R over M sub 2 raised to the power of M sub 2 over M sub 1 minus 1. And we're gonna substitute the values, so that's gonna be I equals 1 plus 0.05 over 2 raised to the power of 2 over 12 minus 1. And we are gonna have a result of 0.00412. And for the N, it's going to be M sub 1 times T, which is 12 times 3, 36. Now let's use the formula in solving the future value of the general annuity. So, future value equals R times 1 plus I raised to the power of N minus 1 over I. And we're going to substitute the values that we have. It's going to be F equals 1,500 times 1 plus 0.00412 raised to the power of 36 minus 1 over 0.00412. And we're gonna have a result, the future value of 58,081.54 pesos. So that means Bathilda will have 58,081.54 pesos after 3 years. Next problem. Edmund deposits 20,000 pesos yearly at an account that gives 3% interest compounded quarterly. How much would he have after 5 years? For this second problem, let's identify the given first. The regular payment is 20,000 pesos, time is 5 years, and the rate is 3% or 0.03, with M sub 1, which is 1 because it's paid yearly, and M sub 2, 4 because the interest is compounded quarterly. So let's get the periodic rate and the number of conversion periods. So for the I, 1 plus 0.03 over 4 raised to the power of 4 over 1 minus 1. And that's going to give us an I of 0.03. While for the N, it's 1 times 5, and that's going to give us a result of 5. So now that we have these elements, let's use the formula in solving for the future value of a general annuity. So we can substitute now. F equals 20,000 times 1 plus 0.03 raised to the power of 5 minus 1 over 0.03. And we have the future value of 106,182.72 pesos. That means Edmund will have 106,182.72 pesos after 5 years. And that's how we solve for the future value of a general annuity. Now let's move on to solving the present value of a general annuity. And these are the formulas that we will use. We will be using P equals R times 1 minus 1 plus I raised to the power of negative N over I. And the formulas for I and N remains the same. Problem number 1. Teles owes Plato an amount of money. He agreed that he will pay Plato the amount he borrowed plus the interest amount. He now pays 1,000 pesos every 6 months, and this will go on for 2 years. How much did Teles borrow if the interest rate is 5% compounded monthly? Let's get the given first. We have 1,000 pesos as a regular payment, 2 years or 2 for time. For a rate, we have 5% or 0.05. For M sub 1, we have 2, and for M sub 2, we have 12. Now let's get the periodic rate and the number of conversion periods. For I, we have 1 plus 0.05 over 12 raised to the power of 12 over 2 minus 1. And that's going to give us an I of 0.03. While for our N, it's going to be M1 times T, and that's 2 times 2, and we have 4. Now that we already have what we need, let us use the formula in solving for the present value of this general annuity. So we will use the formula P equals R times 1 minus 1 plus I raised to the power of negative N over I. let us substitute. It's gonna be P equals 1000 times 1 minus 1 plus 0.03 raised to the power of negative 4 over 0.03. And that's gonna give us a present value of 3,717.10 pesos. Which means Thales borrowed 3,717.10 pesos from Plato. Now let's proceed to the second problem. Benson invested in a car loan. The car is payable for a year and he should pay 30,000 pesos monthly. How much is the car if the interest is 10% compounded quarterly? For the second problem, let's get the given first. For the regular payment, we have 30,000 pesos. For our time, which is 1, rate 10% or 0.10. For M sub 1, we have 12 since it's paid monthly. And for M sub 2, we have 4 since the interest is compounded quarterly. After this, let's get the I and the N. So for the I, it's going to be 1 plus 0.10 over 4 raised to the power of 4 over 12 minus 1. And that's going to result to 0.0083. While for the N, we have 12 times 1 and that is 12. Now that we have what we need, let us solve for the present value of this general annuity in this problem. So we're going to have 30,000 times 1 minus 1 plus 0.0083 raised to the power of negative 12 over 0.0083. And that's going to result to the present value of 341,307.47 pesos. That means that the car Benson loan cost 341,307.47 pesos. So that's how you solve for the present value of a general annuity. And oh, we're almost done. Now we're off to solving the regular payment of a general annuity. In solving for the regular payment of a general annuity, we will use these formulas. If the future value is given, we will use F over 1 plus I raised to the power of N minus 1 over I. While if the P or the present value is given, we will use P over 1 minus 1 plus I raised to the power of negative N over I. And the formulas for I and N remain the same. First problem. Galadriel wants to save 100,000 pesos in 2 years for her tuition. She decided to add a constant amount to her savings every month. How much is her regular payment to her account that offers 8% interest compounded quarterly? As usual, let's get the given first. So in this problem, what do you think 100,000 pesos is? Is it a present value or a future value? Correct, it's a future value. So yeah, let's put that in our given. Future value is 100,000 pesos. For our time, we have 2. For our rate, 10% or 0.10. And for M sub 1, 12 since it is paid monthly. And for M sub 2 is 4 since the interest is compounded quarterly. Before we proceed to solving the regular payment for this general annuity, let us solve for the periodic rate and the number of conversion periods first. So for the periodic rate, we'll just substitute. It's going to be 1 plus 0.08 over 4 raised to the power of 4 over 12 minus 1. And that's going to give us an I of 0.0066. While for N, we have 12 times 2, and that's going to give us 24. Now that we have the necessary elements, let's now solve for the regular payment of this general annuity. Since the given is the future value, we will use a formula with a future value, and that is R equals F over 1 plus I raised to the power of N minus 1 over I. So if we substitute the values, it's going to be 100,000 over 1 plus 0.0066 raised to the power of 24 minus 1 over 0.0066. And as a result, that's going to give us a regular payment of 3,859.08 pesos, which means Galadriel adds 3,859.08 pesos to her savings monthly. Second problem. Geralt borrowed 30,000 pesos from Yennefer. He pays her once a year, which will go on for 4 years. How much should Geralt pay yearly if there is a 4% interest compounded monthly? For this second problem regarding regular payment for general annuity, let us get the given first. So this 30,000 pesos here is a present value. So there we have present value 30,000 pesos. For our time we have 4. For our rate 4% or 0.04. M sub 1 is 1, while M sub 2 is 12. Now let's get the periodic rate and the number of conversion periods. For the I, if we substitute it, we have 1 plus 0.04 over 12 raised to the power of 12 over 1 minus 1. And we have an I of 0.04. On the other hand, with the N, we have 1 times 4, and that's going to give us 4. So now let's solve for the regular payment of this general annuity. Since the present value is given, we will use the formula which uses the present value. So that is R equals P over 1 minus 1 plus I raised to the power of negative n over I. And we're gonna have 30,000 over 1 minus 1 plus 0.04 raised to the power of negative 4 over 0.04. And we have a regular payment of 8,264.70 pesos, which means Gerald pays Jennifer 8,264.70 pesos yearly. And that's all for solving general annuities. And we're done. Simple annuities, check. And general annuities, check.
That was challenging.
I agree, but we got through it.
What about you guys?